Quick video on rules of exponents. Going to just do 4 quick examples here. First thing I would do with this one is I would just keep in mind that this is the same as x to the 8th over 1. I'd multiply straight across, and that would give us x to the 8th over x to the 3rd. Remember, we have this rule over here that says that we have x to the m over x to the n, that we really have x to the m minus n. So that gives us 8 minus 3 is 5. So that gives us an answer of x to the 5th. All right. Same thing here. No, not the same thing here. Something different here. We know that if we have ab to the n, what we really have is a to the n, b to the n, which reminds us that exponents are distributable over multiplication. So what we're going to do here is this is crucial to us, is that we get this times this, and then this times this. So what does that net us out? Well, it nets us out 2 to the 3 times 5, so 2 to the 15th. If this was anything, well, if this was simpler and I could convert this into a number, I would. It's just not easy. I don't know what 2 to the 15th is. It's a big number. Then we have x to the 10th. Excuse me, so x to the 10th. And there's our solution for this one. Right? So I guess what I'm trying to get back to over and over is that if you know the rules of exponents and you have them and you can use them consistently, this gets a lot easier. Hold on a second. I have more. I have 2 more examples somewhere in here. So here's the next one. We're going to use 2 rules here. One is the rule that we just used, which reminds us that exponents are distributable over multiplication. So I'm going to do that. So as I do that, I'm going to get x to the negative 2y to the negative 2. I'm going to look at these as if they were different, so if you don't mind, just to show you how that would look. And then what we know is this. If we have x to the negative n, it is the same as 1 over x to the positive n. What we need to remember is that negative exponents make fractions. Negative exponents cause fractions. Negative exponents don't cause negative numbers. So what we're going to do is we're going to take the reciprocal of this one and the reciprocal of this one. So it's going to flip them over and get 1 over x squared times 1 over y squared, otherwise known as 1 times 1 is 1, x squared, y squared. All right? Hopefully you're seeing the pattern here, and I think this is going to be very doable as you keep practicing this. This last problem is not more difficult, it's just more involved. You can do this a lot of ways. You can distribute the exponents in here, so we'd have x to the 5th y squared. This multiplication sign is this one, so we'd have x to the negative 4 y to the 0, because negative 1 times 0 is still 0. But we also know this, that any number a to the 0 is equal to 1. It's equal to 1. This is crucial for us to know. It's really crucial for us to know. With the exception, a cannot equal 0. All right? So let's get rid of this because we know y to the 0 is 1 and x to the negative 4 times 1 is x to the negative 4. We just did this on this problem up here. So we know that x to the negative 4th is the same as 1 over x to the positive 4th. So when we multiply this out a little bit more, we'll get x to the 5th, y squared, because remember it's this whole thing over 1, isn't it, over x to the 4th. We're going to focus now on this piece of algebra right here. So x to the 5th over x to the 4th is just x, and x times y squared is x, y squared. And there's our answer. So I hope this was really helpful for you. These things are really doable. What I suggest you is just do a ton of problems so you can just see it over and over and over. And as you do that, it will get much, much easier for you, I think. So thanks for watching. If you're not already subscribed, please subscribe, and your comments are always welcome.